Hello, welcome to Magic. My name is Richard, and today we'll be going over how to create a DApp on zKsync using Magic, specifically Magic's SDK to handle authentication and wallet provisioning. So what you're looking at here is Magic. It's a link to or a place in our documentation that goes over how you can implement zKsync. I will put all the links to what I go over today below, such as a link to this doc, a link to zKsync itself, and I also want to point out that we kind of assume that you have a Magic account and you know how to create an application, which is actually pretty easy. I'll go over that real soon, and that you will be able to follow along with some code, specifically in a Next.js application. So if you're comfortable with React, you are in the right place. Now, in our blockchain sections in our doc, this is our zKsync. It's a very, very short kind of like, hey, this is how you set up the zKsync. We have code snippets, goes over what we're compatible with, and some links that you'll need to develop the zKsync DApp yourself. Now, today, I'm going to make things a little simple, at least for me. Hopefully it will be for you too. And kind of introduce you to or remind you about our quick start demo here. What this is if you've created an account and you've logged in and you've created an application, as soon as you create the application, this is what you'll see. This is a quick start little section right here. And I'm just going to, well, this is zKsync here, but I'm just going to start it at Ethereum testnet and show you that zKsync is actually already part of the quick start guide. So that's kind of the point of that. There's this CLI command right here. I'm going to copy this and I will find the place in my machine. I'll post it, and I'm just copying exactly what was behind this, right? And I'm going to name this zKsync demo, and we'll wait for this. Cool. So it seems like this is already running. There's also a position, or there's also a repo in our local machine. So I'll check out both. First, localhost. And here we are. So I'm not logged in yet. This is what we'll kind of test it, test our code on. And we don't need to be here anymore, but I'll keep it here. And I'm going to open a place. I'm going to open, let me open a new terminal, and let's see, it's asking me for a quick update. We'll get that out of the way, and let's go to the place in my machine where we can open this code base, and here we go. Okay, so today, what I'm going to do is essentially use our quick start demo and just kind of reconfigure it slightly in a way so that it works with zKsync. And let's go over some of the files that we're going to be touching today. So in the .env, this has already been preset. Okay, so we'll keep this open for now. In the source, utils networks, see how here that zKsync is kind of already part of one of the networks that you can set up. By the way, this is not like specific to like Magic. You don't absolutely need to do this to use Magic SDK. It's just that our quick start demo has several other networks that you can configure, and this has been included in their kind of like quality of life addition, so it makes things easier for you. And I'll get into where in our code we use this enum or these functions here. So I'll leave this open for the time being. Okay, so let's see, components. Magic provider. This is, again, I say this a million times here. I'm not trying to make a joke. This is not a pun, but this is really where the magic happens. Lines 27 through 33. This is where you are constructing magic. You're pulling in the API key that was in the .env file. You are also using some methods or functions that you're pulling in from the utils networks that I showed you earlier, right? Because we want this quick start demo to be kind of ready for you just to use on any network easily. And so messing with things in network will help you kind of test things out. So once we create magic, we're storing it, and then we are obviously like storing it, and then through the provider, we are going to extend it out to wherever else it's needed. Okay, so that's what this is. This is a magic provider. Now, once we're logged in, or I guess I should say the process of logging in happens in auth, email OTP. Here, super simple. We've exported magic out, so we're using magic.auth, and then the login, you pass in the user's email address, and then the user will start their authentication flow. This method or this SDK call in this kind of format here means that you guys will be using Magic's UI. It's our UX. The user will be taken through a flow. You can white label that. Again, not the purpose of this video, but just want to point that out that we will be triggering line 25, specifically the handle login function, and you'll see that. Once the user is logged in, it's going to query the blockchain and get that user's balance. It should be 0, and we'll get that in the cards, user info card to be specific. Get balance is being called, and you'll see that. I'll point that out. And then finally, we're going to send some tokens out, of course, and that's in the send transaction card. And it's going to be, we're using Web3.js. And so we'll be calling the send transaction function. So these are kind of the files we'll be going over, right? And so let me just kind of set this up here, okay? So we're going to be on zKsync Sepolia, okay? And so in the .env, I just want to make sure that that's where we are, okay? And the reason for that is because magic provider, told you this is where the magic happens, right? When I'm creating the magic instance, it is pulling in the RPC URL on the chain ID for what chain I'm on. And what chain I'm on is determined by what I pass into the next public blockchain network variable here in the .env. And so when I go over to network and I call get network URL, it's going to know that I am, give me a second here. This is going to get the blockchain network that I set in the environments file. It's going to be zKsync Sepolia. We'll pull in this RPC URL. And again, same thing with zKsync Sepolia. Same thing with the chain ID. Okay, so that's really all the .env is. This is not, or the networks is. Okay, we won't get too caught up in this. And so let me just kind of take you to the login flow now. So we'll close this. I have the zKsync Sepolia Block Explorer open and ready. And here's the application. I'm going to open up the console. I'm going to log in, passing in my email address. This is where that magic.auth.login with email OTP, passing the email. That's what I'm talking about right here. And when I click on this, it's not a white labeled flow. You are relying on Magic's UI and UX. We will display this to your user. We will send a 6-digit email OTP to the user. The user will go ahead and get it, then post it. And first time login, the user is going to have a wallet created for them. Returning users won't have a new wallet created. They're going to want the same one. And they're not going to have any crypto in their wallet. There's no preceding. The reason I have this is because I've been playing with this application for a little bit, testing it before making this video, so it should be 0.00 for you. But what I'm going to do is I will send maybe a little bit more in, just so you see that you can do that. So I'm going to send, this is my address here. I'm going to send myself 0.01 more. I'm going to send, and it's pending. And if I click on refresh here, there you go, 0.03. So I've sent some to myself, and we'll just pause right here real quick, okay? I'm gonna go back to the code and show you. Okay, we've created the magic instance, get this out of the way. Again, here, this is the login, right? We clicked on the email submit, it passes it in here, and then the rest of this goes on. I'm logged in, okay? And then as soon as I'm in the protected page, the user info card is essentially this right here, this user info card. It shows what I'm connected to, my email address, my wallet address, and my balance. And so it's getting the balance using web3.eth.getBalance at my public address. It's then holding it to set balance, holding it to balance. The address we're actually getting from local storage, because once we logged in, we actually held it there. But you can easily just also get it by using Magic's SDK methods, magic.user.getInfo. It will get information about the currently logged in user, the authenticated user, such as their email address and their public address. And on the login, we probably pulled it out that way and then stored it to local storage, and which is why we're pulling it from there. But in any case, this is the user info card. Now what I'm going to do is now send the transaction out. I'm going to send it back to myself, and again, it's using Web3. When I click on, when I pass in the wallet address and an amount, it will then allow me to create a transaction object. By the way, this is EIP 1559 supported. This also comes from the network here. Some networks are, and some networks are not, right? Supporting 1559. So in the case that 1559 is not supported, then we'll pass in the gas price and create, we'll do that legacy gas calculation thing. If it is, then this is not passed in, right? And Magic, before sending it the signed transaction off to a node, we will actually pass in some default gas parameters for you if you don't already have it. If you pass in stuff like max fee per gas, max fee priority per gas, if you pass those things in, that takes precedence. If you don't pass anything in, we'll populate that for you. So in our case, 1559 true, so this will be ignored. This is going to be sent out. And let's see what that looks like here. So I'm going to send myself some crypto, some zKsync Sapolio 0.001, whatever. We're going to clear that, clear this, and we'll send the transaction. So it's waiting, there's a transaction hash, there's that, successful, great, refresh. Okay, we got some crypto has gone out. I'm going to check my wallet address on the MetaMask side, and yeah, I've got it. We will click the transaction history down here. It'll open up a new tab with, there we go. So, by the way, here is the 0.01 that I sent myself. Here's the 0.001 that I just sent out on the zKsync era Sapolio testnet block explorer. Now, we're not going to go over, interacting with the contract, and like I said, doing more complex stuff, which zKsync allows you to do. Today's video was just to show you that it's really easy. It's just create an account, copy these 5 lines down, create a running application, playing with it, and then from here on out, you can start, implementing more complex and amazing things that the zKsync doc, not here, the zKsync doc actually helps walk you through. And so hopefully this video gets you started in the right direction. Again, all links to all the resources that I've used, including even how to get faucet testnet tokens. I'll include a link to that below as well. So thanks for listening in, and please share what you build. I'm eager to hear about your project. Thank you so much. Bye-bye.